Very good morning, students. How are you? I think you are safe and sound. Last class I had done simple problems on viscosity. Okay, so I think the problems are clear to you. And I had discussed some of the units also, and I have given some of the list of the formulas also. Fine. So let me recall the formulas and units. Then I'll forward to the next set of problems. That is surface tension, bulk modulus, and capillarity problems. Fine. Then, so what are the units? That is force, it is in newtons, pressure, newton per meter square, work done. So 1 joule can be written as 1 newton meter. Understand this? Fine. So power 1 watt is equal to 1 joule per second, or 1 kilowatt is equal to 1 kilojoules per second. Fine. Then 1 Pascal is equal to 1 Newton per meter square, 1 kilopascal is equal to 1 kilonewton per meter square, 1 megapascal is equal to 1 meganewton per meter square. So density formula already you know, mass by volume kg per meter cube. Specific weight W is equal to rho into G Newton per meter cube. Specific volume V is equal to 1 by rho, that is reciprocal of density meter cube per kg. So volume to liter conversion we have discussed, that is 1 liter can be written 1 into the 1000 centimeter cube, 1000 divided by the centimeter cube should be converted to meter cube. So it is 1 by 100 centimeter to meter, it is 1 by 100. So total centimeter cube, total is 6 zeros will come because 10 raised to 3 is there, centimeter cube is there. So 6 zeros will come. So 1 by 1000 meter cube will come. So viscosity we discussed, that is mu is equal to tau by du by dy. So if it is in poise, okay, so it should be like divided by 10 Newton second per meter square. If it is in Newton second per meter square, then it's into 10 you have to do. Okay, not to convert to poise. So SI units to poise into 10 you have to do. Suppose if it is in poise, you have to divide it by 10. Okay. So kinematic viscosity, mu by rho, that is meter square per second, and if it is in Stoke, so it is in centimeter square per second. So 10 raised to minus 4 meter square per second. Right? So for gas relation, P by rho is equal to RT. R value is 287 joule per kg Kelvin. Then bulk modulus K. Now we are going to discuss problems on bulk modulus. Okay. So it is bulk modulus K can be defined as compressive stress to volumetric strain. Again, compressibility can be written as beta is equal to volumetric strain divided by compressive stress. So it is reciprocal of bulk modulus. So therefore beta can be written as 1 by K here. Fine. So therefore K value is, already we have derived the relation in previous slides also. That is K can be derived as minus dP by dV by V. Surface tension. So there are three cases will be there. One is on liquid droplet, and one is hollow bubble, and one is liquid jet. Clearly he will mention in the problem. A liquid droplet or a soap bubble. Hollow bubble can be called as soap bubble. A liquid jet. Like that, if we mention clearly, then according to that you have to substitute the equation. So capillary rise, H is equal to 4 sigma by rho GD. Fine. So capillary fall, H is equal to 4 sigma cos theta by rho GD. Fine. So if you give straight angle for capillary fall or capillary depression, fine. If it's not given, take it as theta is equal to 128 degrees. So these, now today's class we are going to solve the problems on bulk modulus, then surface tension and capillarity. Fine. Let me start one simple problem. So it is continuation of viscosity. So I may give one problem on based upon this. It is very simple on viscosity. Then we'll move on to the next set of problems. Fine. If the velocity distribution over a plate is given by, velocity distribution is given, u is equal to 2 by 3y minus y square Okay. Then u is in velocity, meters per second, y is in distance. Determine shear stress at y is equal to 0 and y is equal to 0.15. Take dynamic viscosity is equal to 8.63 twice. So he has given something about velocity. Okay. Distribution or plate he has given something velocity. Then where to determine shear stress at y is equal to 0 and y is equal to 0.15. Tau we need to find. Tau at y is equal to 0, tau at y is equal to 0.15. Fine. Then given is equation he has given something velocity he has given 2 by 3y minus y square. Then therefore du by dy is equal to, okay, so 2 by 3 minus, so differentiate. So because on differentiation if we use du by dy is equal to 2 by 3, okay, then minus 2y on differentiation. Therefore du by dy at y is equal to 0. Therefore at y is equal to 0, y is equal to 0, you substitute that one. So 0.667 it will come. So du by dy at y is equal to 0.15 you substitute. So something value will come here. So given mu is equal to 8.635, convert that mu into SI units. Okay, divided by 10. If SI unit is given, then if I want to convert into points, into 10. That's all. 8.63 divided by 10 Newton second per meter square. Now we need to find shear stress at y is equal to 0, shear stress at y is equal to 0.15. Now shear stress tau is equal to mu into du by dy at y is equal to 0. So equation is known to me, substitute that one. Tau is equal to mu, we know, mu he has given, and du by dy also it is known, at y is equal to 0, at y is equal to 0.15. Substitute all the relation to obtain tau at y is equal to 0, tau at y is equal to 0.15. So tau at 0, 0.5756 Newton per meter square it will come, and at y is equal to 0.15, tau at 1.5 it will come 0.3167. So this is simple problem if you use directly velocity in terms of equation. So first differentiate that one. Okay, first write the set of equation, differentiate between, then find at y is equal to 0, find at y is equal to 0.15, then substitute that y is equal to 0 and y is equal to 1.5 to obtain tau. Okay. Now let us move on to the next set of problem, that is bulk modulus problem. Very simple, just you should know the equation, that's all. Everything will be given. Just we need to find the equation. Fine. Determine bulk modulus of elasticity of liquid. We need to find K. Okay. If the pressure of liquid is increased from, his case, he has given 70 Newton per centimeter square to 130 Newton per centimeter square. So pressure has been increased from 70 Newton per centimeter square to 130 Newton per centimeter square. The volume of liquid decreases by 0.15%. So pressure increase has given the value and volume of the liquid decrease as well 0.1. In terms of percentage he has given. Fine. Now given is initial pressure he has given 70 Newton per centimeter square. Okay. Then final pressure he has given 130 Newton per centimeter square. Fine. So increase in pressure dP. dP is called as increase in pressure. Okay. So 130 minus 70, that is dP is equal to 16 Newton per centimeter square. Now decrease in volume 0.15%, that you convert divided by 100 if I do. Okay. So decrease in volume. So write the equation, that is bulk modulus K is equal to dP by minus dV by V. Right? dP by minus dV by V. This is bulk modulus K relation. So here minus dV by V is, so already minus it is there, okay, because there is a decrease in volume already, that value it is in negative, that is minus 0.15%. So minus into minus gives plus, okay. In the previous section, if I say already decrease in volume, if I say it is a negative value, minus 0.15. So that minus 0.15 already in the equation it is minus dV by V. So minus into minus plus 0.15 divided by 100. That is how dV by V comes into picture. So therefore, so dP it is known to me 16 Newton per centimeter square, and minus dV by V value is known to me. So find, so you'll get the answer K is equal to 4 into 10 raised to 4 Newton per centimeter square. Right? So this is how, if K value you have to remember here. Okay, K equation you have to remember, that is K is equal to dP by minus dV by V. So therefore you can find the value of K like this. Fine. Now one more problem on bulk modulus. What is the bulk modulus of liquid which is compressed in a cylinder from a volume 0.0125 meter cube at 80 Newton per centimeter square to a volume 0.0124 meter cube at 150 Newton per centimeter square. Well, so what is the bulk modulus K? Again we need to find, of liquid which is compressed in a cylinder. Volume he has given, pressure he has given. Volume he has given, initial volume he has given, and initial pressure he has given. Initial volume he has given, and final pressure, final volume he has given, and final pressure he has given. Okay. So initial volume V is equal to 0.0125 meter cube. Final volume he has given 0.0124 meter cube. Okay. So volume gets decreases. You have to see this value also. Okay. See the values. So what are those values? That is V. You can see the value 0.0125. Higher to the lower value gets decreases here. Sometimes what happens, if you give lesser value and the final volume is the higher value, if you give, then plus will come. So like that you need to understand the values. Okay. So 0.0125 meter cube, then final volume has given less value. Final volume is less value, 0.124. So it is, volume gets decreases. Right? So decrease in volume. Okay. So dV is equal to 0.0125 minus 0.0124. dV value will come 0.0001 meter cube. So minus dV by V, that is minus 0.001 divided by V value is known to me, 0.0125. Okay. So therefore initial pressure and final pressure also he has given. So increase in dP. So 150 minus 80, 70 Newton per centimeter square. Therefore K is equal to, okay, dP by minus dV by V, already it is in minus, so positive term will come. 70 divided by that value, that is d minus dV by V value. Therefore K is equal to 8.75 into 10 raised to 3 Newton per centimeter square. This is how the values are given direct. You need to get substituted here. Fine. So problems on surface tension. Now I think the problems on bulk modulus are clear to you. So problems on surface tension. So now let us solve one or two problems. Okay. Now the surface tension of water in contact with air. The surface tension of water in contact with air at 20 degrees Celsius. At 20 degrees Celsius is 0.0725 Newton per meter. Fine. The surface tension of water in contact with the air at 20 degrees Celsius is 0.0725 Newton meter. What is this 0.0725 value? So I told you units are very important. You need to understand this. Newton per meter. If I say it is which parameter, means which parameter talks about Newton per meter. So Newton per meter, if I say it is surface tension. So the value it says about surface tension. Fine. Then the pressure inside a droplet of water. Now understand this. So there are three cases I told you in surface tension. One is liquid droplet, one is hollow bubble or soap bubble, and one is liquid jet. So this problem it is based upon which case? That is liquid droplet or droplet of water. So the pressure inside a liquid droplet or droplet of water used to be 0.02 Newton per centimeter square. So pressure is given. One Newton per centimeter square or Newton per meter square. So it is pressure greater than outside pressure. So this pressure it is greater than outside pressure. Okay, fine. Calculate a diameter of droplet of water. Calculate diameter of droplet of water. So you need to calculate the diameter of that liquid water or liquid droplet. So in the problem, try to understand. He has given surface tension. Okay. Then he has given pressure. You need to calculate the diameter. So given is sigma, he has given 0.0725 Newton per meter. So pressure he has given 0.02 Newton per centimeter. That you convert into meters into 10 raised to 1 Newton per meter square. Then to find diameter of droplet. So we know the equation when the relation talks about when there is a droplet of water or liquid droplet equation, that is pressure can be written as 4 sigma by D. And if it is a hollow bubble, 8 sigma will come. Just you have to write the value 8. Okay. So P is equal to 4 sigma by D, or PV it is known to me and sigma is known to me. Calculate the diameter. Okay, so therefore D is equal to, that is 4 into 0.0725 divided by 0.02 into 10 raised to 4. So it is in 0.00145 meter will come. If I stop up to that, or if I want to write in mm also, you can multiply by 1000. Meter to mm, multiply by 1000. If I do, then mm it will come. No problem. Okay. If you want to stop up to the meter, you can stop up to that value. D is equal to 0.00145. If you ask in mm, specifically the liquid droplet is mm or something like that, into 1000 if I do, it will come in mm. So I written units also in terms of meter of it will come. The conversion also I written here. That is sigma, it is in Newton per meter. That is 0.0725 value, it is Newton per meter divided by Newton per meter square. Newton gets cancels and meter gets cancels. It will come in terms of meter. Okay. That is how the conversion can be done. Fine. I think the problem is clear. So direct substitution is there. You need to know the equation. Then what exactly is given. Conversion is very important here. Without knowing conversion, you cannot proceed to the problem, or the answer it will become wrong. Right? Example 2. Find the surface tension in a soap bubble of diameter 40 mm he has given. Soap bubble. soap bubble or hollow bubble. When the inside pressure is 2.5 Newton per meter above atmospheric pressure. Okay. Then diameter is given 40 mm, that you converted to meter. Meter to mm into 1000, mm to meter, it is 1 by 1000. So 40 into 10 raised to 3 meter. Fine. Therefore, P is equal to 2.5 Newton per meter. P is equal to 2.5 meter pressure he has given. Fine. Therefore, I know for the pressure intensity on soap bubble 8 sigma by D. 8 sigma by D. That is sigma is given sigma. So we need to find sigma here. Fine. So pressure he has given, diameter is given. We need to find sigma. Therefore, sigma is equal to 2.5 into 40 into 10 raised to minus 3 divided by 8. So Newton per meter. So sigma units are Newton per meter. So 0.0125 Newton per meter. Fine. So this is the simple problem for a soap bubble. Now let us understand the simple problems on capillarity. Okay. Then calculate the capillary rise in a glass tube of 2.5 mm diameter. You are need to calculate capillary rise in a glass tube of 2.5 mm diameter he has given. When immersed vertically in water, second case is mercury. Take sigma is equal to 0.0725 Newton per meter for water, and surface tension sigma is equal to 0.52 Newton per meter for mercury in contact with air. Specific gravity of mercury is given 13.6 is given, and the angle of contact 130 degrees is given. Right? So angle of contact, if he has not given, assume that theta is equal to what? 128 degrees. Nearly it will be 130 or something like that. Okay. Assume if theta is not given, assume that 128 degrees. That's all. Now in the problem he has given diameter 2.5 mm, that is 2 mm to meter, 2.5 into 10 raised to 3 meter. Then surface tension for water he has given, then surface tension of mercury he has given values, and specific gravity he has given, that is 13.6. Convert that. Okay, so we know specific gravity is known to me, then I can calculate what? Density of the fluid. Okay, density of the fluid can be calculated. Specific gravity is what? Relation specific gravity, that is S is equal to density of liquid to density of standard liquid. Okay, density of liquid to density of standard liquid. So specific gravity is known to me and density of water is known to me. You can calculate density of liquid and density of fluid. That is the relation of specific gravity. Therefore, rho is equal to 13.6 into 1000. That is specific gravity into density of water. So this is how you have to convert, or you have to obtain the relation for density here. Fine. So everything is known to me, then I can proceed to the problem. So to find the capillary rise of water. So I told you for capillary rise of water in case of for water, the angle of contact will be almost all it is 0. Okay, so almost all it is 0. Therefore, theta is neglected there. 1 degree or 0 degree can take it. So there you can neglect the theta here. Okay. Therefore, H is equal to 4 sigma by rho g d. It will come. So this is the relation for capillary rise. Okay. So 4 into sigma is known to me. surface tension is known to me, then density of water is known to me, 1000 into G, acceleration due to gravity 9.81 into the diameter. Okay, he has given. So we have to obtain capillary rise, that is H for water. Right? Therefore, H is equal to 0.0118 meters. Or if I want to convert into centimeter, okay, then 1.18 centimeter. Fine. Then for mercury, we need to find capillary rise for mercury. So mercury theta angle is given, that is 130 degrees. Fine. That is H is equal to 4 sigma cos theta by rho GD. Okay, that is 4 into substitute that value sigma cos theta and the density of mercury. So that is what we need to convert. Density of mercury is different, and density of mercury is given 13.6. That you have to convert to density of liquid. Okay, specific gravity is given. Specific gravity of mercury has given 13.6. That you have to convert to density of fluid. So you know the relation already I told you. So 13,600, how exactly we come? So G 9.81 into 2.5 into 10 raised to minus 3. Therefore H is equal to, it will come in terms of negative. It will come in terms of negative, that is minus 0.004 meter. So negative sign indicates what? It is a depression. Positive sign indicates what represents? Rise, capillary rise. So negative sign indicates it is the depression. Fine. So that is how you need to understand what is exactly capillary rise for water and capillary rise for mercury. Fine. The problem is clear. So we need to calculate capillary rise H. Okay. Then for water we need to calculate, and for mercury we need to calculate. Okay. Then all the values are given, diameter is given, surface tensions are given, specific gravity is given. Then obtain for capillary rise for water and capillary rise for mercury. So whatever the values that are coming, if it is positive means it is a capillary rise, if it is a negative means it is capillary depression or capillary fall. Right? So that is how the simple problem regarding capillary rise. Okay. Now let us understand the another problem on capillarity. Find out the minimum size of glass tube. We need to find minimum size in the sense size of the glass tube we need to find. Immediately in our mind it will come what? The diameter. Okay, find out the minimum size of glass tube means the size of the glass tube means it indicates it is a diameter we need to find. That can be used to measure water level. That can be used to measure water level. If the capillary rise in the tube is to be restricted to 2 mm. So capillary rise it is restricted to how much? 2 mm. Surface tension of water in contact with air. Surface tension of water in contact with air is 0.073575 Newton per meter. Surface tension he has given, sigma he has given. Fine. Now we need to find what? Diameter. So in the problem he has given, H he has given, H is equal to 2 mm. Okay, convert that mm into meter. Then surface tension he has given. Then for water I told you, so it is 0 degrees, angle of theta for water it is 0 degrees. Therefore again we know density of water is equal to 1000 kg per meter cube. So this is for water. Okay. Then therefore H is equal to 4 sigma by rho GD. This is for water relation, capillary rise for water. If it is for mercury, or if it is for depression, or if it is for mercury, then 4 sigma cos theta it will come. Because in mercury what happens? The angle of inclination will come into picture. But in water, between the glass tube and the surface of that capillary rise of water, the angle of contact will be very small, either 1 degree or 0 degrees. Okay. Therefore, for capillary rise, I written the equation H is equal to 4 sigma by rho g d. Therefore, H has given, then sigma has given. Okay. Then density of water is known to me and G is known to me. Then find the diameter, that is 0.015 meter, D is equal to 1.5 centimeter. So these are the very simple problems that can be asked in exam. So one set of problems will be on like viscosity. Okay. Then one set of problems on like bulk modulus, one set of problems will be on surface tension, one set of problems will be on capillarity. Okay. So in exam, any one set of like anyone's based upon any one concept, he may ask the problems. Okay, very simple. It is a direct substitution. And the thing is, you should know the equation. That's all. Okay. If equation and units are known to you, the conversion of units, then you can solve the problem. Okay. So these are the very simple problems that will be there on the three concepts, that is bulk modulus, surface tension and capillarity. Okay. So in next class I will try to do in module 2. Okay. The just I'll do the second chapter. In module 2 I'll do one set of chapter. Okay. Then in module 1 I'll do one set of chapter, module 2 one chapter, like that. In all the modules I'll do one chapter. And then later on I'll try to cover the remaining modules, particularly whatever the chapters that are left behind in particular modules. Fine. So next class, in like Microsoft Teams, I'll try to post the questions, assignment questions. Okay. Everybody, okay, A, B, C sections, everybody, okay. So you have to submit those assignments online itself. Okay. Everybody submit those assignments, okay, and post it in Microsoft Team, particularly in fluid mechanics. Separate channel is there in Microsoft Team, that is 4th semester. FM subject is there, okay. So everything you try to post in that fluid mechanics channel, okay. Everything, the submission of date and everything I'll give you, okay. Even like all the questions I will pick from question papers, okay. All the questions I'll pick from the question papers. Then I'll set, or I'll give a certain set of questions. Try to solve those questions, okay. I will send the material in Microsoft Teams, okay. Everything I'll send that materials with the photocopy I'll send. Try to solve those theory as well as problems, okay. So for your assignment, the assignment for you is solve the problems, theory as well as problems in assignment, write in assignments, okay. So I think already it has been intimated to you, students, there will be no online internal test. There will be no online internal test. There will be a offline internal test. Remember this. So DD has been they have decided in meeting, or VT itself, it says it is no online exams will be there. There will be, even I am talking about final exams also, there will be no offline exams will be there. No like directly they won't pass. No auto promotion will be there. Remember this, because VTU has given strict orders. They are going to conduct the exams. They are going to conduct the exams. So even for test also, in meeting it has been decided there will be a offline exams, no online exams. So remember this. So try to like uh, uh, show interest. Okay, try to show interest whatever the videos we have uploaded. Okay, uh, just go through that one videos. I think most of you have not even until now. Most of you, I'm telling, most of you have not seen the videos. I request you, because these pandemic situations will be continued, but for exams it will be offline. That I'll just make a point that one. So whatever it may be, but they are going to conduct online test. Okay. Those who have not seen the videos, please go through that videos, irrespective of the subject I am talking about. Okay, not only my subject, irrespective of the subject. Go through that videos, understand, because you are in second year, self-study preparation, self-preparation should be there. So we are here only to understand you the concepts. So remaining thing you need to, okay, mug up the things, or like you need to read by yourself. Fine. So everything will be covered. Almost all every concepts will be covered. But the thing is, you should show the interest. I think if I am seeing the attendance, almost all 50%, only like 50% attendance is there. Please, I request you, go through the videos, because immediately after like lockdown is over, then the internals will start. Okay, so therefore, so again we won't repeat the things. So whatever doubt is there, please message me by my private WhatsApp number. Fine, that is 9844739393. This is my WhatsApp number. Please message me. Okay, then I will also message you. Okay, you can interact with me, because almost all I have finished the first chapter in module 1. Okay, so if any doubt is there, any concept you didn't understand, message me privately anytime. I am free anytime. There is no time restriction is there. Okay, anytime if you are free, okay, then message me. I'll try to interact with you. Any concept, any problem, anything, directly you can also call me also, no problem. Anytime you can disturb me, anytime you can call me to my number, then you can clear your concepts. Fine. So this is what I am going to give some one message for you. Okay, so this is the final class for this first chapter. Okay, then tomorrow I'll start the module 2. So whatever the chapter that is which is easy for you, or whatever the chapter if I want to continue, I'll do it in next class. Thank you, students. Stay safe and take care here. Thank you very much.